Dear students, now we are going to take up study in the chapter motion on a plane, the topic projectile motion, and first we will be studying ground to ground projectiles. Now this video consists of two videos, one followed by the next one. The first part is what we are now doing, at the end of which you please watch the part 2 of the same topic. Now in this part 1 we will be covering the development of the 4 standard formulas for ground to ground projectile. Namely, what are those formulas? Time of flight formula, then maximum height reached formula, then horizontal range formula, and then the fourth one is the path equation of the path, which is a parabolic equation. Therefore, these 4 standard formulas, how we are going to derive this uh, from fundamentals. Therefore, it will be a basic. Now, this video is a basic. This part is the basic fundamentals of the ground projectile. And as I said, then after finishing it, you please continue with the part 2 of 2 video, which is a separate video. There we will be covering the standard concepts which are involved in the ground to ground projectile, and also how to apply the formulas as well as the concept for solving problems. Therefore, we will be taking up for worked out examples the past asked NEET as well as JEE Main questions. Several of them will be doing around 20 questions here. At the end of which, I also will be giving you a list of the PYQs, past asked questions, for you to do practice. Okay. Now with this, we will now get on with the topic deriving the standard formulas. Dear students, we will now take up study of projectiles. Suppose you throw a stone or a ball from a point on the ground. This is the ground. On then from a point on the ground, this is the point. If we throw a stone or a ball, then the path it takes is it goes like this, and then it comes back and then hits the ground again. Let's say at this point. Now the path is a curve, as we know. This is the vertical direction, this is the horizontal direction. Let's call it as x direction and y direction, like this. So then the path it takes is, in mathematics, it is called as a parabola. Now, when we threw the stone, we gave it an initial velocity at this angle with the horizontal. Let's call it as theta. And then the velocity which we gave to the stone, let's call it as u. Therefore, u is inclined. U is a vector which is inclined at an angle theta to the horizontal. And therefore, we can resolve the initial velocity u in terms of its components. Horizontal components is u, this is theta, therefore horizontal component is u cos theta, plus the vertical component will be u sin theta. That is at t equal to 0. As it is climbing up, the curve is showing that its trajectory or the path is like this. It is coming. This is the velocity at this particular point. What we say is, what is the displacement at a particular point is given by the tangent to the curve at that point. So then we draw a tangent at this point. This is the velocity, let's call it as v. And then we know that the velocity reduces as it climbs up. Now, there is another thing is, now why it actually reduces is because there is acceleration due to gravity, g is pulling downwards. Acceleration due to gravity is a constant retardation, g, and therefore now the vertical velocity is becoming reducing Whereas the horizontal velocity, there is no acceleration component on the horizontal direction. Therefore, it stays as uniform velocity u cos theta. Therefore, one thing is that after some time t, let us say at t equal to t, now the velocity vector v is composed of two components. Horizontal component, there is no change because it is moving with uniform velocity along the horizontal direction, because there is no retardation or acceleration along the horizontal direction, along x direction. Therefore, this remains as u cos theta. Whereas the vertical velocity is undergoing a retardation g, therefore this becomes initial velocity is reducing by means of gt. So let me just draw it bigger. Now at this particular point, let me now show the magnified picture. At this point is like this. This is the path curve at that point. Then we draw a small tangent to the curve at that point. That is the direction of motion at that particular point, instantaneous motion, and then the velocity vector there is v at time t, and the v has got component, horizontal component remains constant, same as what is the initial component, plus the vertical component is now becoming u sine theta initial minus gt. So, and therefore as now time increases, as time increases, you can see that the gt value goes on increasing. That means minus higher value, therefore velocity. This is called, let us now call this as velocity y direction component. Let's call this as velocity x direction component. The velocity y direction component is going on reducing as time is increasing, because of the gt value goes on increasing until when it reaches the highest point of the curve. It now reaches the highest point of the curve. Afterwards, it's going to come down. Now, at the highest point, the velocity component at this point, a velocity is going to tangential to the path or the curve. Therefore, this is going to have only Vx. Therefore, V equal to Vx, because Vy at that point is going to be 0. Therefore, what is now the time at which now the Vy component is becoming 0 is, we have to put that u sine theta minus gt equal to 0 at that point, at t equal to. Now, there one more point which we should realize is that the path of the curve, which is a curve what we have called as parabola, is very symmetrical about the vertical half. That means now this side is very same as this side. Whatever happens in this from t equal to 0 until it reaches the topmost point is going to take place in the reverse direction when it reaches a bottommost point like this. Therefore, now the time which takes from initial t equal to 0 to reach the topmost point, let us call it as capital T by 2. Why capital T by 2 is that at time t equal to t by 2, because now the capital T, let me just call it as, is a full time of flight. That is the time it takes to come back to the ground. Therefore, this being exactly symmetrical, half the time it has gone up, and on the other half the time is going to come down. Therefore, the time at this particular point when it reaches here, let me call it as capital T by 2. Therefore, when you put this particular t equal to capital T by 2 here, you get now t equal to 2u sine theta by g. Therefore, now this is the time of flight. Therefore, this formula is very important. This is a very standard formula to be memorized. This says the total time of flight of a projectile which is ground to ground. I call it ground to ground because it is thrown from a point on the ground and then reaches back to the ground. Therefore, this is called as a time of flight of a ground to ground projectile, is given by the formula t equals 2u sine theta by g. This is the very first standard formula. Let me call it as a standard formula. Because as we go along, I'm going to give you some more standard formula, after which we will deal with non-standard formula, which also you need to memorize, but then which is not generally given in all the teaching books. Therefore, let us call this as no standard formula number 1, which is the time of flight. Next, we will now deal with what should be the formula for the maximum height reach. What is the maximum height reach? Now this, as I said, this is the path of the projectile parabola. Therefore, now symmetrically it reaches the topmost point. At this point, now the total height from the ground, let me call it as capital H. That is what I am going to call it as. H is the maximum height reached. Maximum height reach is going to be given by another formula. Let's now calculate what is the maximum height. What happens is, now as it is traveling, let us now call this as maximum height, and therefore there is one more term also which I will now give. Now this is called the range. Range actually means what is the maximum distance, what is the distance at which it falls back to the ground from the initial starting point range. And then, as I said, because it is now symmetrical, now this is a half range r by 2. Now let me call the range as a symbol r. Therefore, this half is r by 2. Therefore, when the x coordinate value of this topmost point is given by r by 2 along x axis and then capital H along y axis, and then we know that all along from the time t equal to 0 to t equal to capital T by 2, it has been traveling along the x direction, that along the horizontal direction with a constant velocity, and therefore r by 2 is nothing but constant velocity, which was u cos theta into time to reach that maximum height we know is t by 2, which is nothing but u cos theta into 2u sin theta by g divided by 2 becomes u sin theta by g. Therefore, this actually is u square sin theta cos theta by g. I'm going to write sin theta cos theta as sin 2 theta by 2, sin 2 theta by 2 g, and then we have one more. This is equal to r by 2, and therefore r is going to be given by u squared sin 2 theta by g. Now this is also is a standard formula. I call it as standard formula number 3. Standard formula, because standard formula number 2 I reserved for the maximum height reached. Therefore, this is range formula. Right? Now we come back to the maximum height reached. Maximum height reached, as we know, is when at time t equal to t by 2. What is the y component? What is the y displacement? Y is nothing but, now we have to apply the constant retardation motion to initial velocity in the vertical direction, that is u sin theta into t minus half g t squared, right? Or you could also use that at initial velocity plus final velocity divided by 2 into time t by 2, right? This is the maximum height reached. Okay, therefore this is nothing but the y, this is nothing but the y value at time t equal to t by 2. Therefore this can be written as u sin theta by 2 into, what is t by 2 is u sin theta by g. Therefore h equal to u squared sin squared theta by 2g. This is the standard formula number 2. Maximum height reach. Formula number 2. So let us now summarize. So far we have got 3 standard formulas. One is the time of flight. Time of flight is 2u sine theta by g. Standard formula number 1. Standard formula number 2, maximum height reached, u squared sine squared theta by g. Standard formula number 3 is horizontal range, u squared, no, it is 2g here, u squared sine 2 theta by g. Standard formulas. And I'm going to give you now the fourth standard formula like this. Now, as the projectile is going up and coming down, let me write the x direction, y direction displacement. X, as you know, is given by the uniform velocity u cos theta. As I repeat, u cos theta is the initial velocity vector on the horizontal direction, and then u sin theta is the initial velocity vector on the vertical direction, whereas in the vertical direction it has got a retardation g, whereas horizontal direction there is no retardation. The horizontal direction travel or the motion is given by the displacement x is given by uniform velocity u cos theta into time t. Therefore, u cos theta into time t. Whereas the vertical direction displacement y at any time, the constant acceleration formula, initial velocity along y direction being sine theta minus half gt squared. Now, I am now trying to get what is the parabola equation, that is the path equation which the stone takes or the projectile takes. Now, how do we get it? Now, this is called as a parametric equations, as you know. Now, many of you who are actually used to mathematical way of thinking, this is called the parametric equation, where the parameter is time t, and then x and y are the coordinates of the point at any time t. Therefore, now if we eliminate the parameter t from here, we get the relation between x and y. That is we get y as a function of x, which is nothing but the equation of the parabola. Now let's now eliminate the t. How do we eliminate the t? From here you take the value of t equal to x by u cos theta, and then put it back into this y. Therefore, y becomes u sin theta into x by u cos theta. Therefore, you gets cancelled, x tan theta minus half g, and then what is t squared is to be replaced by x squared by u squared cos squared theta. Now, therefore, now in this equation is connecting y and x. Therefore, and there is no t involved here. We have eliminated the t. Therefore, this is the parabola equation. Equation number 4 is given by y equal to x tan theta minus half g x squared by u squared cos squared theta. This is the fourth equation, standard equation. Standard formula rather. Okay, understood? Right. Dear students, so far we have studied the ground-to-ground projectile, the derivation of the standard formula, 4 standard formulas we have seen. Now next we have to now take up the standard concepts involved in the ground-to-ground projectile, as well as also then practice a few worked out examples. That will be covered in the second video of this particular series, which is called the motion in a plane, projectile motion, and part 2 of 2. Therefore, you please continue with the part 2 of video, which is a separate video. As I said, there we will be covering the development of the concepts, standard concepts involved in the ground projectile, and also we will follow up with practicing a lot of questions. I'll work out the examples with you so that you get to know how to apply the formulas as well as the concept. They're all pretty easy questions only, and then all of them have been asked in the past to NEET as well as JEE main questions, and then questions on this chapter, especially the ones which I am now going to present in that particular part 2 video, or simple funda kind of problems, direct application of the formulas which you have now so far learned. Subsequently, later on in other videos to follow, we'll be taking up tougher questions and then very kind of mixed concepts as well as now the non-standard formulas which I'll be teaching you before we actually now try out those. Therefore, now continue with the part 2 of 2. Thank you.